This is Mick Elliott, Electronic Specifier at Embedded World. I'm on the Analog Devices stand with Fiona Treacy, who is the Managing Director, Industrial Automation for Analog Devices. Earlier today at the show, Fiona gave a keynote speech on Intelligent Edge, how it helps the factory of the future. So first of all, Fiona, maybe you could just run through some of the key points, the overall points of your presentation.
Yeah, absolutely. So our presentation today really focused on the idea that industry and factories consume a lot of energy. They consume about 50% of global energy. So if we want to conserve energy, that's the best place to start. And in this, we want to pivot to renewables, which is, going to account for future energy about a quarter. But we actually need to make the energy we use today more efficient. We need to drive productivity and utilization. And that was basically the essence of the talk. And then how we can use intelligence at the edge and capture real-world analog signals to enable a data-driven transformation. So by intelligence at the edge, we can capture new insights. We can understand how energy and power is used and consumed, not just within a component, like what Analog Devices makes, but actually between components, most importantly at that system level. And then when we look up to the whole factory, it's actually from machine to machine, so that we're optimizing energy and efficiency at all of the elements within the signal chain or within the actual production chain.
Okay, and what's the development? What's the pathway for developers moving towards a factory of the future?
Yes, absolutely. So I guess one of the things I said at the keynote this morning is this is fundamentally an engineering problem. And that's really good news because central to our DNA and ADI, and obviously the audience, is solving complex engineering problems in unique and innovative ways. And that's about taking and orchestrating what we have in terms of new smart sensing capabilities, actuation, precision measurement, all this evolution in terms of connectivity, and then computing power at the intelligent edge. And that's, of course, to engineer us out of this problem. So while it's a daunting challenge, it's also an inspiring challenge. And what we see on the stand here at Analog Devices and throughout the exhibition in general is all of these really innovative technologies that will enable us to add more intelligence to the edge, add more sensing capabilities, even to run AI locally and machine learning algorithms. And they bring one key benefit in the fact that they are much more power efficient. You can run them on a low power, for retrofitting, for example, for a factory, you can run on a battery powered system, Edge AI right now, right? And the big benefit, as I mentioned, is faster decision making. And with faster decision making comes more responsive equipment. So when we're taking that efficiency problem at a full automation level, you see more responsive equipment means more accurate output, means higher yield, higher productivity. So it's a compounding effect. But it all starts out at the simple edge.
And more specifically, what Analog Devices will offer, if we take it, if you like, from the component level up to, do you put these on a board for developers? So, yeah, if you could just talk us through that. Yeah.
No, so that's a great question. So Analog Devices makes a whole host of semiconductor products, and these are obviously industry leading. But what we're seeing is a move in the industry to put more of these together at a system level. And like, for example, just take robotics, more robots in a factory. We're seeing the need to put them together at a system level around core functional groups within the robot. So what we've actually developed is a number of platforms for a robot like an AMR. So we have a battery management platform based on our industry-leading battery management systems. We have a wheel drive platform, and the wheel drive platform uses our precision motion control and our trinamic motion platform. That's to give you really high accurate precision motion and precision wheel steering. We also have, what's really important for any of the robots of the future is real-time awareness, perception and awareness. So we have actually demoing out here a sensor fusion platform which leverages our 3D time of flight technology to give you really accurate depth sensing. So humans and robots can interchange and it can perceive the environment around it much more accurately and respond quicker. And also connectivity within the robot. All of this could be connected by GMSL, so high-speed links. And of course wireless to connect back to the factory network, because a lot of the robots are now mobile, so we need like private 5G networking to get back onto the IT/OT network. And what's really important then is how we stitch these hardware platforms together, and that's through open source ROS, the Robotics Operating System. And it's not an ADI, it's open source frameworks, but it stitches these multiple different hardware platforms together. So that's just one example if I take a use case of a robot, but there's obviously a whole host of other examples as well.
And what about the software development? Where do you support the developer there?
So ADI is investing in software, and it's a big focus for our company moving forward. We have over 1,000 software engineers working on some of these problems.
Conjures up a vision.
They're not all in the one place. And you can see some of our software platforms actually that we're demoing here today, including actually security, and security is another one in terms of the Cyber Resiliency Act that comes up a lot in terms of the capabilities we're adding to our chips to make them secure at a hardware level, but also to enable key exchanges and other key software features like secure boot, secure update, root of trust, etc. So all of our hardware is coming with software-enabled analog, so a whole host of driver platforms to make it really easy for customers to deploy some of that hardware. And then as we add more and more digital capability, supporting more of the standard ecosystem in terms of software and tool chains.
And just a quick question on security on the chip level and system level.
Yeah, so as I mentioned, security is a key area that everybody is talking about right now. And obviously it depends on the product, what level of security. And one of the things ADI differentiates itself in the market is really working with customers to understand the system level problem and putting the appropriate amount of security at the right place in that system. So I know outside here we were showing at one of our connectivity demos, that's all around Ethernet connectivity and time-sensitive networking, the ability to have both mission-critical control traffic and non-mission critical traffic share the network, ensure they're not compromised in time. And in those we have special security features, like I briefly mentioned, hardware root of trust, secure boot, secure updates, so that nobody can tamper with individual nodes within a network, which can be often an entry point, for example, for a threat.
And I guess different customers are looking for different solutions. Can you give us some idea of maybe, from simple to complexity of what customers are trying to do?
So I think customers are actually trying to remove complexity, and there's a whole trend around getting to market faster. We have the pressure in our own company to get our products out faster, and we see it with all the customers we deal with every day. They want to build systems and validate them quicker. So some of the things ADI is doing is obviously putting these things together at more system levels. That could be in terms of a module. It could be in terms of more of a board level project, and sometimes it's working with partners to get them into a system, which might be like we mentioned 3D time of flight, working with somebody to get that into actually a camera system. And that's all about removing some of the complexity, and depending on the customer, they want us to do more or less in different domains as well, more and less in hardware, or more and less in software. And we are innovating in all of those core aspects, but most importantly, we're trying to get as close as possible to the system level problem, because that enables us to innovate, and it also enables us to provide unique solutions, because the obvious way to solve it is not always the best way. And by really working in collaboration with the customer, we can understand where we can have a true impact, and we can bring that then to market through silicon, or it could be through software, or it could be through a tool chain.
And clearly this is going to be a growing market over the coming years.
Yes, look, I think it's a time of transformational change, particularly in the industrial space. I know it's something that excites our team back in the factory in ADI every day because there's new challenges and new opportunities, but most importantly, we can see the impact we can have on making things more efficient, on driving productivity, on helping engineer a sustainable future.
Okay, Fiona Treacy, thank you very much.
You're welcome.